Hello, and welcome to Part 5 and the conclusion of the 1960s Japanese-made Univox U45B guitar amplifier project. So next, we need to get the PCB board and the two transformers back into the chassis and hook up a power cord so that we got juice to run everything. But before we can do that, we need to hook up some wires to the PCB board so that we can reconnect the PCB board to the jacks and pots and tube sockets and whatnot.
It's now time to introduce Mrs. Owegi and let her have control of things for a bit.
So, here we have a bunch of pre-cut, pre-tinned wires, ready to be mounted and soldered to the PCB board. All the wires have been cut a little long, to allow for some wiggle room and tweaking of how the wires will be run, after the PCB board is mounted back into the chassis. Here are the 3 shielded input cables. This end connects to the 3 input jacks. The extra copper shielding will be removed from this end. The pre-tinned wires here connect to the PCB board. The green wire connects to the shielding of all 3 cables and is used for the ground connection. The heat shrink tubing around all 3 of the input cables is used to bind the cables together, to make their PCB board connections a little more rugged and durable. And here's a look at the PCB board of Squidapus, with all the wires connected. Note the solder lug connected to the green ground wire for the input shielding ground. In this picture, we can get a better look at the 3 shielded input wires. Without the heat shrink tubing binding the 3 input cables together, each cable would be free to move in all directions, increasing the risk of the wires weakening or breaking at its PCB board connection. In this picture, we can get a good look at the solder lug connected to the green grounding wire for the input cable shields. The solder lug will be mounted at this point here, and have a path to chassis ground, using the same nut and bolt used to secure the PCB board to the chassis. So, now that the PCB/Squidapus is all wired up and ready for installation, it'll be set off to the side, while the rest of the chassis gets prepped for the PCB board installation. Now it's time to get the rest of the ground wires hooked up to the 3 potentiometers, as well as the guitar input jack that is located on the outside of the chassis. Here we can see the black wires used to connect the 3 potentiometers, as well as the guitar input jack, to ground. Here's a better look at that guitar input jack. Notice the black ground wire coming through the hole in the side of the chassis and connecting to the ground lug of the guitar input jack. The ground lug is also tied to the switching lug of the jack. This is a quick overview of the bench while working on this part of the amplifier project. Time to move on to the power cord. Here we can see a black wire running from one side of the power switch to one side of the fuse holder. Here the black hot wire from the power cord has been connected to the other side of the power switch. Originally, the power cord was installed using a rubber grommet and zip tie. This was tried first in the hopes of not having to drill the chassis hole larger for the power cord strain relief to fit. It might not be an expensive old tube amplifier, but it's an old tube amplifier nonetheless, and Owegi just doesn't like drilling and cutting up old amplifiers any more than needed, if it can be helped. Well, some of them anyways, others are just plain mod fodder, have no mercy. However, the rubber grommet for this power cord was eventually removed, the hole drilled out larger, and a power cord strain relief was used. It just wasn't solid enough with the rubber grommet. We probably should have known better, but we tried anyways. Amplifiers, I mean life, goes on. Here's a quick look at how things were set up originally when using the rubber grommet. And here's a quick look after the strain relief was installed. In this picture you can see that the rest of the chassis had been wired up before deciding to give up on the rubber grommet attempt. Notice the juicy orange drop resistor in the background. Notice the black tape around the fuse and fuse holder. Just a quick way to minimize the electrical zapper doodads, zapper DAs. So, time to get the heater filaments wired up. Here's a quick look at the heater filaments wired up. Take note of the blue wire running from the 6.3 volt heater supply. It runs to the power indicator lamp. One last quick look at the heater filament wiring before moving on. And here are a few quick pictures of the speaker jack wiring. At this point the PCB board / squidder puss has been mounted back into the chassis, but hasn't been wired up yet. Here's a closer look showing the solder lug attached to the green wire that goes to the shields of all three input cables. You can see how it's been mounted using the same nut and bolt used to secure the PCB board to the chassis. Here's a look at the chassis with all the PCB board wires connected to their corresponding component connections. In this close-up you can get a good look at how the add-on ad hoc negative feedback loop is mounted and wired up. From this view you can see how the potentiometers and input jacks have been wired up. And last, but not least, here is a look at the back of the PCB board mounted to the chassis. So, with everything wired back up, it was time to do the initial power tests to make sure there wasn't any shorts, etc. But hold on, Bat Alien, something's not right. Unfortunately, somewhere along the way, while being stored and moved around, etc., the thin wire that runs from the 50 mA solder lug into the power transformer broke off at the transformer end. Not good. If you look close at this picture, at the 50 mA solder lug, next to the PT solder lug with the red wire going to it, you can see a little solder joint where the new 50 mA wire has been connected. A little bit of the paper from the power transformer had to be removed to get to a place to solder the new wire in, but everything went smoothly and the power transformer is back to working just fine now. With the power transformer repaired, the initial power tests continued and everything tested fine, so onto the tubes we go. So, being happy with the power tests, it was time to install the tube retainers and tubes. Here's a good look at the tube retainers installed on the tube sockets. And here we have all the tubes installed. The 6x4 and 6B-M8 tubes are original. The 12A-X7 tube was dead on delivery and had to be replaced. For the fun of it, here are some pictures of the tubes lit up in different lighting. This picture was taken in pretty much normal room light, maybe a little dimmer, but not much. A little darker in this picture. A lot darker in this picture. Oh, the glow of glorious vacuum tubes. Or should I say valves? Or perhaps glass tubes with valves in them. Whatever we choose to call them, they are glowing objects of great sonic beauty. With the amp up and running, let's come back to the add-on ad hoc negative feedback loop to test how well it works or doesn't work, and/or how well it sounds or doesn't sound. To make things easier and to keep the Zaptronic non-funners down, let's build a switch to engage and disengage the negative feedback loop. Here's a real close-up of the top of the switch. And here's a look at the inside of the switch. Here's the switch and a diagram to show what's connected to what in the up and down positions. In the up position, the green and orange wires are connected, and the blue and red wires are connected. In the down position, the brown and orange wires are connected, and the white and red wires are connected. Here's a diagram showing the switch in the up position and how it is wired up and connected within the circuit. Note how the add-on ad hoc negative feedback is inserted between the cathode of the 12AX7 tube and its K2 connection to the PCB board. Here's a diagram showing the switch in the down position and how it is wired up and connected within the circuit. Note how the cathode of the 12AX7 tube now connects directly to its K2 connection on the PCB board. So, with that, let's have a bit of fun messing around with the negative feedback in both its up/engaged position and its down/disengaged position. Switch up, negative feedback engaged. Switch down, negative feedback disengaged. Switch up, negative feedback engaged. Switch down, negative feedback disengaged. Switch up, negative feedback engaged. Switch down, negative feedback disengaged. Switch up, negative feedback engaged. Switch down, negative feedback disengaged.
Okay, now that the amp is back up and running, I want to come back to the inputs and address the voltage divider and the attenuation that it's applying to the input signal to the amplifier. I've already have the signal generator set up so it's putting about 1 volt out, and that's coming into the center input jack. These are the 347K input resistors, so that 1 volt is coming to the top of the center input resistor. The 2 outer input resistors are in parallel and go to ground, which form the voltage divider. So at the bottom here, we should have the attenuated signal of about 0.3 volts. Let's see what the meter says. At the top, we have an input voltage signal of about 1.057 volts. And at the bottom, we have the attenuated signal of 0.352 volts. So the voltage divider is being used to apply quite a bit of attenuation to the input signal to the amplifier, leaving us about 1/3 of the original input voltage. So that ends Part 5 and concludes the 1960s Japanese-made Univox U45B guitar amplifier project. Thanks for watching.